Good evening, viewers. Thank you for tuning to my channel. At this point in time, I want to explain another question. Okay, boss, Mr. Man, I don't know if you want to pass me on this face light. God bless you. I want to actually explain this system of questions that I came across, and also to recall and emphasize on the key rules when you are naming organic compounds following the IUPAC system of naming. As such, there are some basic rules that have been laid down when you want to name organic compounds. So this particular structure that you are seeing, this is the structure that we came across. I'm going to put it very well for you to understand. Now, this is the structure. I don't know if you can see it well. This is the structure. Yes, you can see it now. This is the structure, and if you're looking at the structure, you can possibly you can see the numbers of carbon atom in that particular structure. Carbon atom, we have 1, 2, 3, 4, 5, 6, 7, 8, up to 8 of them. Some are acting as an attachment, and also we have 2 chloro compounds that have been attached to that particular structure. So the first thing you need to do is to locate the longest possible continuous chain and make it your parent hydrocarbon. In this system of naming, you need to be very, very careful, because some students may may look at this particular structure and say that the longest possible continuous chain is 1, 2, 3, 4, and 5. They will stop at 5. But the rule says I will locate the longest possible continuous chain and make it my parent hydrocarbon. So you can agree with me that the longest possible continuous chain is 1, 2, 3, 4, 5, and 6, the one we have number 6. And you must understand the fact that there are 6 carbon atoms in the longest chain. You have 2 attachments. The alkyl group, which is the methyl, is attached to carbon atom number 4. You can see one here, you see another one down. And also we have 2 chloro compound, one attached to carbon atom number 2 and carbon atom number 3. And also you have a double bond in between them. So as such, how do you assign priority? Student A assigned from this other side, that is from right to left, which is correct. The reason being that this double bond is superior to the attachment. This double bond is superior, that's why the numbering comes from this side. And as such, if you want to look at the naming of this particular compound, I have written the naming at this side. I have written the naming. The naming says 2, 3. You use comma to separate when there are 2 attachments. When there are 2 different when there are an attachment in different position, maybe the same attachment but in different position, you use comma to separate the numbers, and you use hyphen to separate the naming. So this is 2, 3. You put the hyphen, dichloro hyphen 4. The 4 here is, we are talking about this 4, the position of the 2 methyl group. 4, 4 di, because there are 2 of them. This one was di because there are 2 chloro compound. Dimethyl hex 2 in. The double bond is attached as a carbon atom number 2. In cases where you are supposed to mention the position of the double bond, you can say 2, 3, and put that in brackets. In that will show that the double bond is in between carbon atom number 2 and carbon atom number 3. That is the video you just saw is a simple explanation to that particular question. There are so many other complex organic compounds that we will bring on board to see how you can possibly name them and assign priority, locate the longest possible continuous chain, and also see how you can play with the naming. And again, I must say this, most students normally find it difficult to assign priority when you are having so many attachments. Most of them do not know which one is the longest possible continuous chain because the JAM will use an attachment to confuse them. But it may interest you to know that JAM have gotten to the stage that they don't write structure for students most time. They write it in condensed formats. As such, I will be highlighting in my next video, that will be maybe tomorrow. In my next video, I'm going to come up with some condensed formula for you, and I'll explain how you can identify them. You interpret it structurally so that from then you can be able to give the name. We can also use the name to write the structure. We can also use the structure to give the name. Anyway it comes. And also the most interesting part of it, I will also show you some letters of the alphabet that you can that is an organic representation, like M. If you write M, we can tell you what M is in organic chemistry. N, compounds like N, compounds like A. We can also name letter A in organic chemistry. All of those things are very simple, and we are going to place it in a way that you will be able to understand. So if you have any anything you want to, any question, you can possibly drop it on the comment section. Do well to subscribe to the channel for more updates. As I said, I will be going live tomorrow, coming up live tomorrow, and I will be explaining a lot of things on organic chemistry, specifically the naming. I want to start with the naming first because most students find it difficult to name organic compound. Once you can name, then we can now enter into chemical reactions of alkanes, alcohol, carboxylic acid, esters, esterification reactions. All those ones are very simple. And how you can name esters, there are also rules. We have rules to them. But for today, why I brought up this particular question is that my student sent it to me, and she said she was finding it difficult to assign priority. So having seen this, I believe she is also online and she's also looking up to this. So do well to subscribe to the channel for more updates. And if you have your questions on organic chemistry or any other part of chemistry, you can also drop it on the comment section and I will do justice to it. Thank you very much. The handler unit, you can basically see it from there at AKFUNQC, capital letter at AKFUNQC TV for more updates on chemistry. I happen to be a seasoned teacher and organic, should I say, a JAM instructor. Have tuition students on JAM for the past 10 years now. And also, I want you to understand that if you want to make it in your JAM, the journeys we started. I think we have started. We started the classes on June 16 for students who want to write their JAM next year, because it may interest you to know that we have 47th topic in chemistry, and in physics, while 18 in chemistry under JAM. And you cannot basically finish that in 3 months if you want to do in-depthly. And also, we have been able to refine all the questions from 1978 that JAM started up to date in all the topic. We've solved them, and we have it with us here. We have it, I think, if I can see one of them in my bag, I can possibly show you. Okay, I think I didn't come with it today. But then we have those questions that we have solved both in organic chemistry, any question in organic chemistry, outside organic chemistry, other topics in chemistry, and also on physics, because I take physics and chemistry with my students on the jam. So these are very simple. We will show you how to answer questions and how you can be able to apply the knowledge in other areas. Thank you very much, and God bless you. Do subscribe to the channel. Thank you. Bye.